Hey everyone, it's Kaylyn, and today we will be going over the 2025 AMC 10B problems. So starting at question 1, the question says, the instructions on a 350-gram bag of coffee beans say that proper brewing of a large mug of pour-over coffee requires 20 grams of coffee beans. What is the greatest number of properly brewed large mugs of coffee that can be made from the coffee beans in that bag? So this is basically just the floor division of 350 over 20, and this would give us 17, which is B. Okay, question 2. Jerry wrote down the ones digit of each of the first 2025 positive squares, 1, 4, 9, 6, 5, 6, ... What is the sum of all the numbers Jerry wrote down? So we know that the ones digit repeats every 10 because 10k plus x squared would be congruent to x squared mod 10, right? So for the first 10, we would have 1, 4, 9, 6, 5, 6, 9, 4, 1 as our units digit. So this is 1 squared, 2 squared, all the way to 9 squared. So if we add all of this up, then we would get 20, 31, 41, 45, right? And then we can multiply 45 by the amount of 10s we have, which is 202, and then we have 5 left, which is 14965. So if we add those, then we would get plus 25. And so if we multiply this out, this would give us 90 plus 25, which is D, 9,115. So that's question 2. Question 3. A Pascal-like triangle has 10 as the top row and 10 followed by 1 as the second row. In each subsequent row, the first number is 10, the last number is 1, and as in the standard Pascal triangle, each other number in the row is the sum of the two numbers directly above it. The first 4 rows are shown below. What is the sum of the digits of the sum of the numbers in the 11th row? So essentially what I did here was I have 10, and then 11, 22, 44, and there's a pretty clear pattern, right? So for the nth row, our sum will be 11 times 2 to the n minus 2. If we wanted to prove this, I guess we could look at these numbers and then take the sums, right? So we would have 10, 1, which gives us 111, and then we would have another 10, another 1, this gives us 2 11s, and then we would have each of these 4 numbers repeated twice, and that would give us double. Okay, anyway, so that proves that the nth row's sum would be 11 times 2 to the n minus 2, and so if n is equal to 11 here, then we would have 11 times 2 to the 9, which is 512, 512, which is 5632. And so our sum would be 16, which is D. Okay, next question, question 4. The value of the 2-digit number AB in base 7 equals the value of the 2-digit number BA in base 9. What is A plus B? So essentially what the question is saying is 7A plus B is equal to 9B plus A. And so 6A is equal to 8B, and so 3A is equal to 4B. And we know that AB can be written in base 7, which means that A and B have to be less than or equal to 6. And the only way that that is possible is if A is equal to 4 and B is equal to 3. And so A plus B would be 7, which is A. Okay. For question 5, in triangle ABC that we have all of those conditions, let O be the center of the circle containing points A, B, and C. What is the degree measure of angle CAO? So we can draw this out. So we have circle O, and then we can have B over here, and then we would have something like that, where this could be A, this could be C. And then we draw out OAOC. So we know that B is equal to 130, and what this means is that angle BAC plus angle BCA is equal to 50. And what that means is that minor arc BC plus minor arc BA, which are this and this are equal to 50 times 2, which is 100. And so arc ABC would be equal to 100 degrees. And we know that angle COA is equal to that arc. So angle COA is equal to 100 degrees. And finally, OAC is isosceles with OA is equal to OC. So that means that angle CAO is equal to angle OCA. And these two are both equal to 180 minus 100 divided by 2, which gives us 40 degrees. So the answer to question 5 is C. Okay, question 6. The line that divides the square region defined by that into an upper and lower region. So let's draw that first. So this is our square region. We have that line dividing it. So I guess we can first label everything we know out. So we know that this length is 1. We know that this length is at x is equal to 2, so 5/3. And so our area of the lower region would be, we know that the height is 2, and so it would be 8/3. And then we have a line x is equal to a, which is right here, and it divides the lower region into 2 regions of equal area. And so since the total area is 8/3, we know that each of these little regions would have area 4/3. And so we know that this is x is equal to a, which means that this is a, this is 2 minus a. And so what that means is that we can call this x. So x minus 1 over 5/3 minus x would be equal to a over 2 minus a. And so what this means is that 3x minus 3 over 5 minus 3x is equal to, we're just multiplying 3/3 over here, so this would be a over 2 minus a. And so what this means is 6x minus, let's move this away, 6x minus 3ax minus 6 plus 3a is equal to 5a minus 3ax. We can get rid of these, and so what we end up getting is 2a is equal to 6x minus 6. So a is equal, I guess we should write x in terms of a, so x is equal to 2a plus 6/6, which is a plus 3/3. And so we would have a plus 3/3 over here. And let's erase all of this. So then we can calculate the area of, let's say, this portion over here. So that would be a times 1 plus a plus 3/3 over 2 is equal to 4/3. What this means is we can multiply both sides by 2. So then a times 6 plus a over 3 is equal to 8/3. And so a times 6 plus a is equal to 8. And so a squared plus 6a minus 8 is equal to 0. And then let's go back up here. By the quadratic formula, a would be equal to, denominator is 2, numerator is -6, plus, because it cannot be minus, because a is positive, and that would be 36 plus 32, which is 68. And so this is equal to root 17 minus 3. And so s is 17, t is 3, and s plus t would be equal to 20, which gives us C as our answer for 6. Okay, moving on to question 7. Francis stands 15 meters directly south of a locked gate in a fence that runs east to west. Immediately, I guess I should also draw this out. So we have Francis over here, we have an east to west fence over here, and we know that this is equal to 15. This would be our gate. Immediately behind the fence is a box of chocolates located X meters east of the locked gate. So this could be our first box, so B1. And an unlocked gate lies 9 meters east of the box, which would be, Okay, an unlocked gate lies 9 meters east of the box, which is over here. I guess we shouldn't call this box B1 then, we should call it B. We have unlocked 1, which is over here, and then we have unlocked 2, which is over here. And Francis can reach the box by walking toward an unlocked gate, passing through it, and walking toward the box. So let's draw all of this out. And let's write out what we know. So this is 8 meters, and then the gate to the box would be x meters, and then box to the gate would be 9 meters. So what do we know? We know that the total distance that Francis would be walking is the same. We know that because this is 90 degrees, U2F would be 17, because 8, 15, 17 is a right triangle. And so what that means is that the distance that he would be walking if he goes through U2 would be 17 plus 8 plus x, which is 25 plus x. And that is also the distance he would be walking if he went through U1, which would be 9 plus the square root of 15 squared plus 9 squared, 9 plus x squared. And then this would be equal to 225 plus 9 plus x squared, which is 81 plus 18x plus x squared. And so then I'll do that up here. You can move stuff around. You would have 16 plus x is equal to, I guess you can square this, is equal to 225 plus 81, which is 306 plus 18x plus x squared. And then if you square that, you would get 256 plus 32x plus x squared is equal to 306 plus 18x plus x squared. You can cancel out everything, so 50 is equal to 14x. X is equal to 25 over 7. If you simplify that, you get C. Okay, that is question 7. Question 8. Emmy says to Max, I ordered 36 math club sweatshirts today. Max asks, how much did each shirt cost? Emmy responds, I'll give you a hint. The total cost was AB.BA, where A and B are digits, and A is not equal to 0. After a pause, Max says, that was a good price. What is A plus B? So what we know is A, B, 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 A must be a multiple of 36. And so what this means is 2A plus 3B must be congruent to 0 mod 3, because it is a multiple of 3 if it is a multiple of 36. We know that 3B is congruent to 0 mod 3, which means A must be congruent to 0 mod 3. We know that A isn't equal to 0, so A is equal to 3, 6, or 9. And since A is the last digit and 36 is even, that means that A has to be even, so A is equal to 6. And so our value would be 6B, B, B, A, and this is a multiple of 36. What this means is that, we should replace the last A with 6 as well. What this means is that since this is a multiple of 4, essentially B would have to be 1, 3, 5, 7, or 9. And this is also a multiple of 9, which means 12 plus 3B is congruent to 0 mod 9. And so then B would be equal to 2, 5, or 8. And the only odd number within 2, 5, or 8 is 5. So B is equal to 5, A is equal to 6. And so A plus B is equal to 11. Okay, moving on to question 9. How many ordered triples of integers x, y, z satisfy the following system of equations? So the first thing I would do was I would flip this to become this. And then I would add each of these pairs individually, so that would give us, for example, z is less than or equal to 2, x is less than or equal to 2, y is less than or equal to 2. And finally, I would add all 3 of these together and then divide by 2, so that would give x plus y plus z. Oh wait, no, not divide by 2, sorry, you don't need to divide by 2 over here. So x plus y plus z would be less than or equal to 6. And then I would list out all triples of x, y, z, which I did during the actual contest. There's only 11, so there's not that many. But just list them out. There's like 1, 1, 1, 2, 0, 0, 0, 0, 2, 0, 2, 0, 1, 1, 0, 1, 0, 1, 0, 1, 1, and there's a few more. But yeah, so that is 9. Question 10. Let f of n be equal to that. Let g of n be equal to that. What is the sum of all integer values of n for which f of n over g of n is also an integer? So first you factor these out. So f of n is equal to, I'm pretty sure -1 works. so x plus 1, and then if you do the long division, then you would get, oh sorry, not x, n plus 1. Then if you do the long division, that would give you n squared minus 6n plus 8. And so that would be n plus 1, n minus 2, and n minus 4. And you do the same thing for g of n. If you do n is equal to negative 1, that works. And then you would do the long division, you would get n squared minus 7n plus 12. So this would be n plus 1, n minus 3, n minus 4. And so now you have fn over gn is equal to, we can cancel out all of the like terms, so then n minus 2, n minus 3, which is an integer, and this is only an integer when n is equal to 2, n is equal to 4. But you see that n cannot be equal to 4 because then g of n, the denominator, would be equal to 0, and so n has to be equal to 2, and so the sum of all integer values would be 2, which is a. And these are the first 10 questions of this year's AMC 10B. In the next video, I will be going over the later problems, so stay tuned for that.